station, you're familiar with that. All of the astronauts, whatever country they're from, are all ham radio operators.
All of them are?
Yeah.
I was on
one of the requirements.
Oh.
It's unfortunate they don't have more time to play with all the ham radio toys that they've got in the space station. First ham radio satellite, you're going to be seeing that. We literally are going to turn around and you can listen to it. Harry Goldwater, before your time, he ran for presidency. The Russian Sputnik, 1951, went around the world and all it did was go beep, 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 beep. Well, back then, you had Radio Moscow, you had all of these foreign stations doing their propaganda and all that sort of thing. Well, Russia said, send us signal reports, listen on your shortwave radios. The reason they did it, Russia didn't have monitoring stations around the earth, and they were depending on the ham radio operators to tell them the signal reports when the satellite, they wanted to know when the satellite went over, how well you heard it, that sort of thing.
So that was their telemetry.
Bingo.
Wow.
Tubes. I got my ham radio license when I was 15 years old. That was 1955. Yes, I'm an old critter. Everything was tubes. Interesting, all of a sudden, solid state came along. Well, did that come from the crashed flying saucers back in out west? Our original ham radio station was located down near the Connecticut River. There was a big flood. It totally wiped it out. That's why this property was built and WNAW constructed. The area where this building is was all woods and trees. I don't think you've ever heard of a rhombic antenna. It's gigantic. It's in the shape of a diamond. That's what used to be on this property.
When was this building built?
1963, 64. The radio station was built in 1937, dedicated 1938. We're going to be going into that. Our Percy Maxim, he was quite a guy. He got the ham radio going. And what really got radio going was the sinking of the Titanic. Other owners of ships said, hey, maybe we should have this newfangled communications device on our ships. That's where Marconi and our Percy Maxim really shifted into third gear and started to get radio stations going around. They were primarily up and down the East Coast and in England, in Europe. That's where most of the ships were going back and forth. Well, tinkerers, ham radio operators, started to build their own spark gaps. And a spark gap transmitter is nothing more like a burst of lightning.
You have one, actually.
I'm going to be playing with it later.
Yeah.
You can actually see the burst. The Navy Department really controlled up and down the Atlantic the radio stations that were doing all of this communications. And somebody in the Navy Department said, hey, these ham radio operators are really interfering with all of the commercial traffic, be it telegraph and all that sort of thing. So somebody in the Navy Department that didn't know anything about radio said, we got to get rid of these guys. Let's push them higher in frequency. Those higher frequencies aren't any good for anything. Well, the spark gap was very, very low in frequency. Well, that person didn't know what they were talking about.
Right.
Anyway, a little bit of history. This is, and you'll be seeing a spark gap. Maybe we can get the thing going. No, it does not put anything out over the air. We don't dare do it. We have all kinds of people out in the parking lot want to know what we're doing. One of many different areas that we ham radio operators get into is emergency communications. The poor people in Puerto Rico, everything was totally wiped out. Got whole lot of boxes behind you. They're full of equipment. Send them out. Radios, antennas, tools. They use it for their communications, and they send it back to us, helping out. The fires in California, pay attention when you see pictures of the fires, especially ridges or mountain ranges. You see lots of antennas. Well, that's police, fire, ambulance, cell phone, that sort of thing. When those fires go through, all of that communication is totally wiped out, be it the power lines that power them, the actual buildings, the equipment, everything. We ham radio operators can step in with portable, we call them repeaters. They're really a miniature relay station using the handheld radios. I wish the news media would go deeper into, like the Boston Marathon. 99% of the communications is done by ham radio using their own radios. The big, what is it, New Year's Day parade out in California. What's the name?
Rose Bowl.
Thank you.
Yep.
All of the communications there is all volunteer from ham radio operators. I've got a box similar to this, much smaller. I can put the radio that I have in my car into it with a battery, go out and do emergency communications for 3 or 4 or 5 days, supplementing the town.
Do you have a repeater in the box?
We could.
We
don't now.
You don't now? They're all out, or you don't have any?
Yeah, they're being used right now, especially out in California. My own town, police, fire, ambulance, public works, all of their communications goes landline to a commercial relay station. Well, we had a bad ice storm, 5 years ago, took all the landlines down. Town was dead in the water. Well, we ham radio operators just came along with our magnetic antennas, put them on top of the police car, the ambulance, or the fire truck, sat next to the dispatcher's desk, and did communications for the town. Town manager said, "Oh, do we?" So this is one of the things that we do quite a bit. Any questions? Okay, we're going to step along. When you had that set up with the talking with the space station, was one of these used?
Not a handheld one. We had we have a permanent one on the roof of our building.
Whoa!
We built
all the shops
14 element. Yeah, all the shops worked on it.
How do you rotate it?
We have a Yaesu azimuth and rotate.
Okay.
Yeah. So we have the whole, and we built in electronics the controller to control from the software we ran Orbitron software.
Excellent.
So we have a little control board that controls the Yaesu.
Excellent.
So it's all tied together. So we didn't do anything handheld.
Okay, handheld. Yeah, I can stand out in the parking lot, know when the satellite is coming over. Take my handheld, plug it in, and have a conversation.
Yeah.
Doing the antenna, but I have got on my radio, I have to be careful of the Doppler shift, so I have to change frequency. Everybody knows the Doppler shift? No? You don't know about Mr. Doppler? What happens when a train is going by? What happens? And it's blowing its whistle constantly.
You never heard the sound change?
Yeah, I have.
The sound changes. Why? Because we have an object that is moving, making waves, be they sound, be they whatever, and they're changing as this object is moving. That takes us over to astronomy. The astronomers can say, this galaxy or star is moving away because it is in the red end of the shift. The star over here is blue and it's coming towards us. That's what Mr. Doppler figured out.
Yeah.
Be it, again, light waves, radio waves, waves in a drop of stone into a body of water, that type of thing. The education material that we have got for people that would be interested is fantastic. Be it on the computer, be it in the remote
bots.
Yeah, those are you got to be familiar with that, right?
I built them here actually.
You did, huh?
Good.
I'm an electronics at Pathfinder.
You built some of your robots?
Yeah.
And I don't mean to interrupt. I'm so
Please.
Somebody left it plugged in, so I don't know if it did a battery drop. It might not work. Nope, it works.
Yeah, I do stuff like this in electronics.
Yeah.
Now, robotics is going to be a big part of your future, your jobs.
Right.
And
We already have a robot head that literally can track and remember who was on and through the camera eyes in our shop.
Yeah,
it's awesome.
They put eyes in it, so it actually
And
it notices that somebody's there and it looks at you.
like my teacher, we
Oh, it's the creepiest thing.
we didn't
It
build
is the creepiest thing.
It was there when I was
the guy who
when
graduated.
I had freshman year. It was there. It was Kyle Lucige's brother, I think.
Yeah,
But it was the creepiest I've ever seen.
but
So
when it hears
we
you
turn
talk,
it
it
on.
goes like this. It looks right at you.
Yeah. So we turn it on freshman year. I'm a sophomore now, but we turn it on freshman year. And Mr. Rogi is my related teacher for my class.
Yeah.
And it scanned the room like 2 times, and as soon as it got back to where the head started from where it was looking, it went right to Mr. Rugg.
That's creepy.
That's
Yeah.
creepy.
That's creepy.
It
Not like
identifies
Sophia
certain
creepy,
people.
But it's still creepy.
Yeah, that's
Yeah, our
weird.
CEO has a robot from the company he used to work for.
Really?
And it dances and stuff like that.
Oh,
that's
yeah,
awesome.
It's about this tall.
Oh,
I've seen those before.
I don't judge him.
so many times people say, why should I become a ham radio operator when I've got one of these things and I can do all kinds of stuff on there? What happens when this thing doesn't
Those
work
things are
anymore?
limitless. Or those things have a limit. Ham radio doesn't.
Right. Becoming a ham radio operator, you learn about components. So let's say you graduated, you're out looking for a job. You go to an electronics place and you say to the human resources person, hey, I know what that capacitor does. I know what that diode is for. I know what that chip does. And the person says, oh, you'd like a job in our electronics factory? Oh, just something to think about. This satellite, previous generation, this is the generation we have going into space now, much smaller, doing
Bigger.
substantially more than previous generations. The orange box, okay, put it in a body of water, be it a brook, stream, river, whatever, it's going to send out information, be it temperature, be it whatever else it is sensing. Pick it up on the ham radio, handheld transceiver. And just one more thing to work with. A lot of extremely good basic information. Somebody says, gee, this ham radio stuff is so complicated. No, it's very, very, a lot of basic nuts and bolts. We call ourselves hams. We get a bit silly sometimes and we build something in a can of
ham.
That's awesome.
Any questions? I feel that the education, getting the word out, is so important to all of you for your futures because electronics is going to be such a big part of it.
You like that, huh, Sean?
That's pretty cool.
You want to build one of those? That's a transmitter in a can.
I want to do that.
Yeah. I don't know what band it is or anything, but it definitely looks like it might even be a transceiver.
I could do this. So
Just put the antenna on here.
Yeah.
You got power input.
The toughest thing about electronics is I just got done building an analog meter, and I just put everything together, put the case back on, tested it. Doesn't work at all.
Oh.
It was the needle the whole time. I'm pretty sure it's the needle the whole time.
It's just stuck.
It's just no. Like even if the polarity's wrong too.
Uh-huh.
So if I put on the polarity right too, the right way, It's still opposite, but it doesn't work.
Oh,
That's the tough part.
yeah, a little research project.
Any questions?
Why is this? Who manufactured this? Or is this something that somebody built to play with?
It's a commercially manufactured.
It is? And I'm confused by
I don't know the
why it would
name
be,
of the
it's for all different
manufacturer.
frequencies, so you can adjust it to whatever frequency. Is that the idea of it?
Yeah.
Oh, I've never.
Undo the clips.
Yeah, move it around.
Be able to take it apart, put it in a little bag, stick it in your back pocket.
Yeah. I've never seen one of those. That's an interesting little antenna.
We ham radio operators use a lot of different types of communication, be it the old-fashioned Morse code. Yes, the Morse code is very much alive and well. The microphone, two-way television. Yes, we do two-way television. Of course, all the satellites. Then there's a whole universe of digital type communication, which we are finding when other modes of communication cease working because of atmospheric conditions. This digital stuff continues to go through.
Can you take a picture of that?
Interesting.
You built some relays like that once.
When we are using the digital communications, there's no microphone. It's all keyboard.
Right.
Walls, floors, ceilings, all metal. The door is metal. It's called a Faraday cage. That is, we have literally built a metal box, or it could be made out of wire. Keeps out any and all other radio signals. We're testing a new piece of ham radio equipment. Again, no pictures. We don't want any outside interference coming in. Close the door, because on the other side of the parking lot, we've got this small brick building that's packed with equipment, and it goes on the air. The parking lot practically lights up with all of the power coming out of the transmitters. This is where we test ham radio equipment. It's something like Consumer Reports, but we don't say to the ham radio operators, hey, that's a good one, that's a bad one. We work with the manufacturers of the various pieces of ham radio equipment, be they Japan, be they wherever, with the exception of Chinese. They don't want to know anybody. And pass that test information along to the ham radio operators. Bob, did you want to do a little bit of a talk?
Yeah, of course.
Come on in.
Ask you.
Sure.
This is Bob Allison. He's pretty much in charge of all of this testing.
How you doing? Hi, I'm Bob.
I told him not to take a picture of the
Can't take any pictures in here. So, hi. I'm Bob Allison. I'm the assistant laboratory manager here, and my main function is to test for QST product review. Now, ARRL is a membership-driven organization. It's a not-for-profit. We're educators and major publishers of technical material. Okay, so our main magazine that all of our members get, and that's 160,000 people, is QST Magazine. And every month in that magazine is a column called QST Product Review. It's like a Consumer Reports for ham radio. And what we do is that we actually order equipment. We buy it off the shelf like every other ham would. Okay? In other words, the manufacturer doesn't give us anything to test. We choose what to test based on our membership input. We purchase equipment like this transceiver here, okay? And we do testing on it in this room. And as Skip mentioned, you're in a shielded box here. We have this shielded box because W1AW is across the parking lot. And they transmit on 8 different amateur radio bands simultaneously at a lot of power. And that energy from all the radio signals can interfere with our test instruments here. So when they're on the air, we close the door and it isolates their RF, their radio frequency energy from this room. So I'll do all these tests. I have a procedure manual that I follow. That procedure manual is actually available on our website. So you can see exactly what I do to test these radios. I actually wrote a book about it as well. It's out in the lobby. And that's to help our fellow radio amateurs. So I will go through all of the tests that we do, and I'll compare what the manufacturer claims versus what I get. And we publish both sets of numbers. And over here in this magazine here, This is QST, okay? And then this is what I do. I put together all these numbers that you see in this book, in this magazine. And there's a little bit more to it than that. And we write about it as well, besides me testing. I get to write about it sometimes, but we have other authors that do the product reviews. They actually do the write-up and stuff, but they're in QST magazine. So a lot of times we find problems that the manufacturer doesn't know about. So early on, we share that test information with the manufacturer, and they get to correct those problems before the article in that magazine goes to print. And so we've been advising the manufacturers of amateur radio for quite a time now. And what we have done is we show them what the problem is, what performance parameters need to be improved on that radio, and gradually they make those improvements. So the work that's done in this room right here benefits amateur radio, and it elevates the technological level of the radio and the performance. So over time, because of our testing throughout the years, we've actually contributed to the advancement of amateur radio technology and technology in general.
And made it a lot cleaner.
This is about as advanced as the military has as far as performance goes. And this is what's called an HF transceiver. And basically, for the most part, you're using this radio to bounce signals off the ionosphere to have it come down far away. And it's using the ionosphere, not a satellite or internet, but purely an operator, an antenna, and a radio. If you have one of those at each end, you now have communications. And the ionosphere is the reflective medium that the signals bounce off of. So that's my spiel.
Okay.
Yes? Oh, this is our test equipment. This is what I use to actually evaluate all of this, the newest equipment. So what is it? Okay, so what do we have here? A dual trace oscilloscope, power supply, test transceiver, so I can listen to what I'm transmitting, or I can transmit.
How do you like that radio, by the way?
That one?
Yeah, because that's the radio we use to make our space contact.
That's a very, very handy radio. It's very, very, very easy to use. And it has a good touch screen. So I like it. Others don't, because it's a weird shape like this. You know, it's what do you do with this thing?
Right.
All right.
Yeah.
But this is a keying generator. Turns the transmitter on and off. A power meter up here, power supply, microwatt meter used for measuring power levels, a signal analyzer, a mixed domain oscilloscope. You can measure RF and look at the spectrum on it, or look at regular time domain signals like a regular oscilloscope. Signal generators to generate signals, simulate signals that you'd hear on the air. We have what's called a distortion meter. It measures audio distortion. It has to be as low as possible. If you want to listen to a radio for a very, very long time, you need the cleanest possible audio. If the audio isn't really clean, you get very, very tired and fatigued after a couple hours of operating. Here we have our spectrum analyzer here, and this instrument's used quite a bit, and we use this for measuring the spectral output, the RF output coming out the antenna jack when we transmit. And right now we're looking at something called transmit IMD. These are distortion products of the audio, the transmitter when you put audio into it. So we will measure these little blips right here on each side, and we want these to be as low as possible. The lower these are, the cleaner the signal that is transmitted. Okay. We have something called a phase noise test set. The phase noise is any noise that's generated when you have a transmitting system and you have a carrier, a little blip of a carrier. Then off at each side of that carrier is noise. So when you have a CW signal, just a signal, you think if it's just occupying just one specific frequency, where in reality there's noise on each side of that. So we measure the phase noise. It's one of the important performance parameters of an amateur radio transceiver. It's called transmit phase noise. It has to be as low as possible. And I could show you what that looks like on a chart real quickly, how it's published real quickly. And if I can't find it immediately, I'll just give up. So don't worry, I won't spend too much time. Can't find my own article in here. But anyway, continuing on. Here's your transmit phase noise right here. And these little lines here correspond to what I have here on the scope. So when I take a trace from here, it goes to my computer in my office, and I can take this trace off of here and put it on a nice little graph for the production department to put into the magazine. So I also, besides all these numbers, I make these little graphy things here.
right? So transmit phase noise. This is another signal analyzer. This is what's called a frequency counter. So I put RF into it. I can measure the frequency in which it's generated at. Right here, this frequency counter is locked to this GPS satellite receiver, and the GPS provides a very, very standardized reference point of 10 megahertz. That 10 megahertz signal is fed into this counter to make this counter extremely accurate.
So it's kind of like a chain reaction.
It's 2 stages. This is one thing telling this box exactly what frequency 10 megahertz is. Once this knows that this is 10 megahertz, all the calibration is spot on.
So the GPS satellites send down a 10 megahertz signal all the time?
Yes.
There's like a tone. Well, you can't hear it.
There's data bits that lock that in.
All of them do that?
Yes.
Oh, I didn't know.
And so usually we get about 5 or 6 satellites at a time, and
you compare them and say, okay, they're good,
something like that's what this does. Yes.
Oh.
We have a computer program that runs inside. Yep. And what else is new here? Well, we can generate waveforms with this. We can measure the performance of what's called a preamp. A preamp just takes a little signal and makes it bigger. Yeah. We can measure the performance of that here. And
actually, that's what failed on our radio contact with the space station. The preamp failed.
Oh. Harder to hear?
It went away, the signal, and we were like, why don't we have the signal? And we switched over to our backup radio.
And you had it.
And we had it. So we knew that something happened.
Well, any kind of static sensitive, static charge can knock that out at times. Or if you have a really strong signal going into the front end when the preamp's on.
170 watts.
All right, so that could. Yep. We'll talk about that.
We waited for it, but it went away.
And that's another signal generator here. A little power supply. I have other power meters. What are the light bulbs for? Sometimes we have to load down an AC circuit. In this case, power inverters. Anybody know what a power inverter is?
Yeah.
Okay. 12 volts DC in from a car battery, for instance, and the inverter produces 120 volts AC out. And that's what we power everything on. We plug things into the wall. It's 120 volts. Well, if you need that 120 volts and you don't have the utilities or the power lines or electricity at all handy, use an inverter. So if you have a battery, you can create 120 volts AC. And what this does, this loads down the AC side so I can make certain measurements to this power inverter. Okay, so that's what the light bulbs are for. Hey, it's great in January. You know, it's like really the dead of winter. It's cold and you want to just feel like, it's summertime again. Oh, doesn't this feel good? It just makes you feel happy. Check it out.
That's way too bright.
Isn't that cool? Of course, look at these are all incandescent light bulbs, right? I think they're outlawed in Germany. Anyway, any questions? Yes, Skip has a question.
No.
Bye, everybody. Oh, no, that's a PC. This thing is a pulse generator. And sometimes I need to simulate noise that's out in the real world. One of the problems with radio reception, as maybe Skip was telling you about, is called man-made noise.
Right.
Power lines can make noise. They can, if you turn on an AM radio, for instance, you hear like that. That's noise. Okay, so there are certain circuitries in modern transceivers that eliminate that. And so what we're trying to do, we have this pulse generator, is we simulate that noise, that man-made noise, and then we evaluate the function on the transceiver that is noise reduction. Where is that over here? Noise reduction or noise blanker. These are the functions on this receiver that takes that out. And we can evaluate that. Okay, I got to move along because our tour guide's telling me.
Skippy's saying, let's
shut
go.
up, Bob.
Thank you.
I'll see you during the kit building session.
Thank you.
You're welcome.
Thank you. Let's go see some old radios now.
An example of older radios, like this one is vintage 1950s receivers. That's the type of things that we started off with. Behind you, antique radios. Here's a good example of a spark gap. There's the 2 wires. There's a gap in between. The power applied. Then you have, and you're going to see in just a minute.
So I've owned all of these
This
radios.
is a real functioning, but it's not hooked up to an antenna.
Spark gap.
Everybody wants to take the picture. This is where it's going to be. That's Morse code. That's me sending,
C2?
I want to talk to somebody, CQ.
Yeah.
That was my ham radio call letters, W1FTE in Morse code. This piece, yes, it's sent out over the air, a burst of energy, and that's all it was in comparison to the sophisticated radio you just saw Bob talking about in the other room. Interesting, this part of it would be connected to lines going around the country, telegraph lines. So the operator here would be listening to this, getting the Morse code, and then putting it out over the air. So it was a dual function piece of equipment. Where it came from, what it did, I'm not quite sure.
Is this just a bigger version of that?
Very, very interesting history on this. This went to the South Pole. The radio operator that was with Admiral Byrd on that expedition was a ham radio operator. Why he used this great big key to key the transmitter, I'm not quite sure. The only thing I can think of is that he did it with his foot while he was operating the equipment with both hands. Okay. That's some very, very interesting history there. Behind you, various pieces of ham radio equipment going all the way from, early 1900s when radio started to...
that was an original one.
You probably heard of the heat kits. That is, you could purchase cardboard box with a whole lot of parts on it, put it together, and then you'd have
that was the first radio I used.
Or various pieces.
I used a Bandmaster.
Excuse me. So this is just our museum here.
Yeah.
We're going to be stepping over here.
Yeah. That was my first radio right there. No, really.
Really?
I had that.
Things have changed.
Yes, slightly. Yeah.
Oh, the first ham radio satellite, they made 3 of them. The first one burned up in the atmosphere. The second one's in the Smithsonian. This is the third one. All it did was go around the Earth and in Morse code just said, hi. The letter H, the letter I. The letter H, the letter I. And that's all it did. Those are the size of the components that were used back then. Now we've got all solid state.
And how long did the battery last?
I think it was a little over 3 weeks.
It just opened this.
20 days. Thank you.
Yeah, 20 days. And then it fell out of orbit, or the battery just went dead?
Burned up.
Yeah, I got one.
Got one?
Yeah. Thank you. Yeah. That's pretty good.
Here's something interesting here. This big gray box came from Arizona, or was it New Mexico? It came from a broadcast radio station, put out a little more than 1,000 watts. The broadcast stations are getting rid of these old things because they can get the same amount of power out of something a little bit bigger than 4 suitcases. So these things are headed to the dump. We intercepted it, resurrected it, put it on a ham radio frequency. As you can see, there's the great big glass tubes that are still used in the old equipment.
So have you been transmitting on this?
Yeah.
It's live?
On 80 meters.
On 80 meters? Oh.
And we're working. Yeah.
Yeah.
It's an AM transmitter.
Yeah. Okay.
And we're working on being able to put it over on 160 meters where there's more and more activity of AM.
Yeah.
Our W1AW repeater, that is relay station. Mm-hmm. Behind us, we've got work stations. Don't drop that thing.
That's one of the tubes that's in there, inside there.
Yeah.
that's the modern day
version of it. Yeah. Is that the same wattage?
Pardon me?
That's the same wattage?
The two of them together are.
Are they? Oh.
But to give you an idea how things are going smaller and smaller and smaller and smaller. And that's old. That's 30 years old.
Yeah.
This is 70 years old, right?
Yeah.
And you need, these light up like a light bulb. You need an incredible amount of power just to heat it up, and you need 3,000 or 4,000 volts here. Okay, pretty lethal stuff.
Yeah.
Right.
Here you need 12 to 35, 40 volts.
Mm-hmm.
Much safer, much more efficient. This is really, pretty solid, right?
Yeah.
But if I was to hit, if this was to break, it's here, feel it. It's a pretty.
That's light.
Yeah, it's full.
Yeah.
Well, I was going to say it's full of air, but it's actually a vacuum. But there's several components in there. One is called the plate, which is right there, connects to here. That's the plate. Then there's a thing called the grid, which if you look in there, you can see a grid of wires. And then there's a cathode. So those are the three components. But again, you need to have several thousands of volts here. Not the kind, which is why you look at a machine like that and you'll see a big stick in the back, which you short the power supply out with. And when you open the door, another latch comes down. So, and it first of all shuts the power off. Then it latches across so you can't. And you have a stick to go in there with. So it's danger. It was here. You can do the same thing, roughly the same thing. Not a one-for-one equivalency.
Right.
And look at it.
But that has a much nicer signal.
Well, yes, these are, sort of. We have a
broadband
fondness for these old tubes, and this one isn't really even that old. The original ones were giant bulbs like this. I have one at home, and it was all handmade, hand blown, and so amazing the difference.
Bunch of artwork that's gone.
And then, if you really want to get down to it, you noticed in that room over there how as you went this way, you started going from older to newer to newer to newer. This will do what almost any one of those big radios out there will do.
Wow.
Takes a little tiny USB, plug it in.
It's like a portable charger.
Yeah.
Portable charger, size of your phone. Right. This has no knobs, but you can go like this on your screen, just like you're used to with your phone, texting or calling up different programs the same way. Look at the difference in the tech. And this does a million times as much as what any of those other radios do.
Yeah.
Thanks, Paul.
But it's way out here in time, right?
Right.
So.
Appreciate that.
But if there's a corona discharge, that stuff will get blown away, and this stuff might survive.
Right. Well, if there's an EMP, right, you want to put those in your backyard.
I will say this about EMPs.
Yes.
We all worry about that and stuff, but most people, and especially radio amateurs, overlook this one big factor. What's an EMP that happens all the time? What's an EMP and a big one that can happen all the time? All the time.
CMEs.
Nope. That's not all the time. That's unpredictable.
Yeah.
That is lightning.
Oh, yeah.
Lightning is your biggest electromagnetic pulse that you can experience.
Yeah.
Because you think about the way radio waves decay, it's it's the inverse of 1 over x squared, or 1 over the distance squared. Right? So lightning can be very, very, very close, right? You've all had close lightning strikes. And if your antenna is hooked up to your radio, you can damage your radio.
Wipe it out.
So that's why it's important to have proper lightning protection built into your station, or simply disconnect the antenna off the radio. In fact, if you're really worried about electromagnetic pulses in your radios, you disconnect the antenna from your radio when you're not using it. And that way the front end won't fry. Okay? If you have vacuum tube equipment, you can leave the antenna hooked up. So what do I have at my house? I have a lot of very modern and somewhat expensive equipment there. Top of the line stuff. But you know what else I have? Vacuum tube equipment. One, it's fun to work on. It's hilariously fun. All the vacuum tubes. You ever see tubes? Any of you?
Yeah.
Ever seen a tube? Want to see a tube? Hold on. Don't go away.
Just going to bring a tube.
I think it's going to be huge.
Yeah.
This is a big transmitting tube.
Yep. Okay,
it's a vacuum tube. What does a vacuum tube have? It has a filament that lights up the tube. It has a cathode, which emits electrons. And it has an anode, which accepts the electrons. And what's in the middle is something called a grid. And the grid controls the flow of energy through the tube. The British used to call these valves. It's like turning a valve on and off. You were turning electricity on and off. But this is a vacuum tube. Of course, there's bigger ones, and there's some very, very small ones, too. Just FYI, now you've seen one.
You know, you guys are talking about ESD, lightning discharges. How many times have you walked across the room to hand somebody something, right? And sometimes if it's dark, you'll even see that little spark in there.
I've seen it, on my fingertips.
Yeah, it's a real pleasant experience sometimes.
And if you work on electronics and you walk across the carpet and then you reach over and you touch the circuitry of what you're building, you can zap the chips, and that's the end of your project. You have to get new parts. So you have what's called an electrostatic mat that you work on. We have one in our screener, for instance.
Not discharge.
And when you build the kits today, you're going to have little rubber mats that your parts sit on. That kind of helps a little bit. Okay. I won't interrupt anymore.
Do it to your friend, right?
We've all seen these things for the TV.
Yep.
We took what the manufacturer put on it to make it go. And we put our own on at ham radio frequencies that we want to use. We have a workshop over here. So many times people say, hey, all of this fancy, expensive-looking equipment. Wait a minute. Get one of these, make our own. Or you can get commercial. We can make our own. I've seen these things thrown away on the side of the road, okay? You take it home and convert it. Ham radio flea markets, there's a lot of good used equipment out there, like something like used cars that work nicely. Questions, please.
Does anybody know what that thing is?
Don't drop it.
I don't expect this part, but what does that look like? If you think you know what it is, just say it.
Tuna can.
It's a tuna can, exactly. So someone didn't have enough money or didn't have a chassis, so they took what they had available and they made
recycling.
They recycled it and made it into a transmitter. Now there's a little bit more modern version of it, which uses a newer tuna fish can, but that's a can that would just go in the garbage. That's a dish that would just go into the garbage, right? They're not going to reinstall that. But a ham radio operator looks at that and goes, you know what? There's a ton of good parts in there. Used to be that way with TVs. Oh, you're throwing a TV out? Oh, the transformer's good, the capacitors, and you built stuff out of it. You know, this is very, very simple. You're not going to go transmit across blanket coverage across the world, but this takes almost no energy, and you can make Morse code contacts across the world with it.
It's awesome.
Out of a tin can and a little piece of board and a couple of hunks of wire, right? You go downstairs, you steal your mom's breadboard, right? Because those are all on breadboards, the radio's over there. And then you look in the car and you see, oh, there's a tin can in there. Okay, I'll save that. This is anything but tin. I think these are steel back then. And then Dad has a pile of wire, so you grab some of that. And the next thing you know, you say, in those days, you saved up so you could buy this transistor.
That was the most expensive thing to buy. That and a crystal.
That and the crystal. And through the magic of technology and your learning and experimenting, you made a transmitter. And the thrill, it's not so much a thrill where you can grab your phone and go, hey, guess what? We're at the ARRL. Here's a picture. Boom, it's out to your friend over on the other side of the world, for that matter, in seconds. But
okay, thanks.
Go to like the next level.
Yeah, it's not critical, but it looks nice right now.
And actually,
So yeah, pull it right there. Just pull it right there.
Joe, are you good at solder?
Okay, but you don't want it falling out while you're working on it. So
Lauren, that's wait for your father.
you can pull the leads and bend it
They're doing
and
actually
just so
really
it doesn't
well.
fall out.
Good for you too, but it's really big for your father.
We're gonna make the
Especially
first one, and then you're
Mr.
gonna do
Warren.
it. So We're gonna put the resistor.
Especially because it's the day after his birthday. His birthday was yesterday.
Yeah, absolutely.
Sort of flat.
Hey, let's do a W1AW group photo.
And then what we'll do is we'll pull this and just.
Oh, yes, absolutely. I got one.
You're kind of weak reported out here in Seattle, but thank you for coming back to me.
That's because we got the beam pointed towards Europe. Tell him he's a 5x9.
Earl, November 7, Echo Papa, you're coming in 5'9". Over here you have Mariusz, Mike, Alpha, Romeo, India, Uniform, Sierra Zulu on a field trip with the Amateur Radio Club from Pathfinder Regional Vocational Technical High School.
Wow, well, I just copied part of that. The band really doesn't cooperate this morning. Must be propagation.
I'm going to sign off with him. Tell him 7-3.
High school, what's the deal on that? Go ahead.
Yeah, we're doing a little quick field trip and a demo here. I'm going to have to sign off for you. Currently N7EP from W1AW.
Cooperating for me. I'm not signing with you unless somebody else works you because a lot of people want to work with W1AW. So thank you for coming back, and I wish the band was a little bit better. W1AW, this is M7 Echo Papa.
Just tell him 7-3.
Okay, 73.
W1AW, 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 calling CQ, CQ.
Kilo 4, Bravo United. Kilo 4, Bravo United.
K4BU. Say it.
Yep, so you gotta repeat that. K4BU
K4BU
from WA1W.
from W1AW.
Stations out there. Came back to me. This is K4 Bravo United. Name here is Guy, Germany uniform Yankee Guy, located near Atlanta, Georgia. Over.
Okay, talk to him.
I'll say hello. My name's Lauren. I'm here on a field trip
Hi, my name's Lauren. I'm here on a field trip
with the Pathfinder Amateur Radio
with
Club.
the Pathfinder Amateur Radio Club.
Yes.
Correct.